Welcome back, chemistry fans. Here we go. We're going to talk about your homework tonight. This is homework number 6, unit 6. I believe this is topic 3, and this is going to deal with limiting reactants. So let's jump into it right away. And so we've got this balanced reaction here, unbalanced reaction. And so we need to first balance this. So let's do that. That's not part of the question, but that's going to be helpful that we do this. So we're going to put a 2 right here to fix our nitrates. Then that means I'm going to have to put a 2 right there. Now everything is balanced. Okay, so that was very simple. I start with 25 grams of the lead nitrate. And I start with 15 grams of the sodium iodide. Okay, if we do that, how many grams of sodium nitrate can be formed? Okay, sodium nitrate's over here. So this is my unknown, and it's asking for it in grams. All right, so I'm going to slide down just a little bit on the screen so we have a little bit more room. You have to solve this one twice. So I'm going to put the 25 over. Now I got to add up all of this. So I'm going to have to go and figure out the weight of lead is 207. The weight of 2 nitrogens is 14 each. That's 28. Plus 48 for the oxygens twice. That's 96. So my total weight there is 331. Now the coefficient in front is a 1. Setting that equal to the unknown amount on the right, 2 times the sodium, which is 23 plus 14 for the nitrogen plus 48 for the oxygen, it's 85. Okay, so now I'm going to cross multiply. So 25 times 2 times 85 divided by 331 gives me 12.8 grams of the product. Well, now we got to do it for the other one to figure out which one is our lowest limiting reactant, our lowest amount of the product produced. And our iodine is of a weight of 127. So 23 for the sodium and 127 for the iodine gives me a total weight of 150, equal to the same exact values underneath on the right. Okay, so I'm going to have 15 times 2 times 85 divided by 2 divided by 150, and I get 8.5 grams. Okay, so now I've got 2 different values, but clearly you can see that this second one is the limiting reactant. There is less of this produced. And the maximum amount that is produced is 8.5 grams of the sodium nitrate. Now, what that means is that the second material is in fact my limiting reactant. My excess underlining it is going to be the lead nitrate. That was the first material that we used. How much excess is there of the lead nitrate? So I'm going to take this 8.5 and I'm going to start it out the exact same way because these are in grams. So I will put it over the 2 and the 85. And then what I'm going to look for is how much of this lead nitrate was there actually produced. So it's 1 times 331. I cross multiply 8.5 times 331 divided by 2 divided by 85, and I get 16.55 used. Now that's not how much was excess. I have to take 25 minus that amount. And this will then tell me that 8.45 grams is in excess. So there is a lot of moving parts in this, and you have to do 3 stoichiometry problems in one whole problem. So thank you very much for your time. I will talk with you again soon. Farewell. Goodbye.